All right, so my challenge now is to print all of the hellos by perhaps using find. So what should I do? All right, let me create an iterator it, but this time pointed to the beginning of the vector. Okay, so here's my iterator it, which points to the beginning of my vector. Notice that when you initialize your iterator like this, the iterator helper object remembers two things: the actual object that it's pointing to, but also the position in that object. So iterator internally is a smart object or helper, little helper object, which knows I am pointing to this container. It remembers the actual container, and it also knows what position it's pointing to. Okay, so let's now have a for loop. Which basically says, all right, we already have something initialized, but then as long as the iterator does not equal ending, actually I am thinking if I have this, how about this? Yes, I'll explain it in a second. This should really be a while loop, I think. While iterator, let me just use a while loop for this demonstration, as I'm thinking this would be the simplest. Okay. Okay, let's take a look at this fragment. So first I create an iterator, right? And I say, okay, I need a container for this, and I need to call the appropriate member function, which will properly initialize my iterator and say, okay, here you are. You are now pointing to this container, and you are at the beginning of that container. Good. Then I create this while loop where I say, by the way, recall that you can compare pointers. Similarly, you can compare iterators, because iterators overload many operators that are naturally supported by pointers, because an iterator is trying to model the behavior of a pointer. Because pointer is so successful in C that C++ Standard Library says, let's not reinvent new interface. We can overload operators. We can create this thing. It will support, you know, assignment, comparison, and things like that. So as long as our iterator does not equal end of the container, which means that definitely there's no need to work with anything else beyond that point, we're just going to say find, use our algorithm that we used before, and say find starting from this position. But our position initially is the beginning, so we're starting from the beginning, right? And we're making sure that uFind should kind of stop the search starting here but ending here. But interestingly, when find doesn't find anything, it returns this. It simply returns the marker of the ending of the container. So as soon as find no longer finds hello, I should be able to, basically this condition should become false, and because iterator will be pointing to end. This is what find is going to do. So I am hoping that this little while loop should print this. Let me comment this out for a second so that we don't have any mix here. So we should really be printing hello 3 times as a result of this loop. So let's find out. Oh, that's bad.
We need to increment the begin counter.
Yes. Essentially, we're finding first instance of hello. right? Which is at position 10 or whatever that position internally is. But then what happens? We are kind of stuck with it because we say, okay, from position 10 now, find it again, and it finds it instantly at that position. So you're absolutely right. Once found, we need to advance the iterator, right? We need to say, hey, iterator, now that we found this thing, move on to the next and proceed forward, right? You're absolutely right. So let's try this. So hopefully this time it'll do something more manageable. Assertion failed. Iterator not dereferenceable. Abort. Okay. So what needs to happen here is that I use find, and eventually it returns the ending. But at the end, recall in this demonstration, the ending is like a non-existing element, right? So the ending of a container, whatever end returns from the container, is non-existing element. You can compare with this position, but you cannot dereference it. However, in my code, what I'm unconditionally trying to print this. So it's going to look silly, but I will basically say if it's almost like, I just say if iterator happens to be, as a result, happens to be the ending position, I'll just break from the loop, right? My code isn't perhaps structured in the optimal way, but I need to protect myself against this, right? And also when I print this 555 right here, let me also display a new line so that we have new lines everywhere. Okay, so let's hope that this gives us more or less readable. Okay, so it finds it 3 times. It finds it 3 times. Also, like I said, we need to take a break. But before we take a break, here's something interesting I want you to also to demonstrate, since I spent so much time coding this. It's really kind of silly example, you know, doing so much work to find those silly hello hard-coded positions. But here's something interesting. Is it, how can I go back from the iterator to position 10, 56, and 17? Of course, I could have like an index, like a counter, and somehow try to count something, but it really doesn't work because find jumps directly to these locations. So how can I go back from, you know, I know that this thing here prints hello, hello, and hello, but every time position changes, can I extract back position 10, 56, and 17? Okay, let's try this. What does exist out there is something that says distance, right? So I can print something like this. So before I print hello, I can print basically the distance from the beginning, in my case, you know, decorated like this, square brackets, distance between string vector beginning position and my iterator, my current position. Let's try this. (10, 17, 56), perfect, right? So there is another, you know, kind of helper function that works with iterators that allows you to measure distances between the iterators, right? So now I know that I started at the beginning. My iterator was perhaps advanced multiple times by the result of find, because find says go ahead, go ahead, go ahead, and so instead of you know, the iterator really doesn't know its position. There is no function of iterator that will tell you, oh, I'm currently at index 56. But there is a way to measure distances from a certain position to, you know, whatever position the iterator is taking right now, and it can be computed by this helper function. I think it's good to know that this thing does exist, and it can give you this answer when you work with vectors. So let's save this and take a break.